Hey guys, Coach Dennis here. I am going to go through this periodic trends assignment just in case you guys were struggling. So we only have to know two periodic trends, one being atomic radius, essentially how big is our atom, and the other being electronegativity, which is how an atom attracts electrons, or basically what pull on the electron does it have, which will be really important once we get to what's called covalent bonding. So I'm going to give you guys a couple ways to figure this out, little easy ways. First, we'll start off with atomic radius. So atomic radius is essentially just the size of the atom. So as we go down each period, our atoms gets larger. And as we go down the row through the period, we tend to get actually smaller. And I'll explain why that is real quick. So with our atoms, remember we have what is called a nucleus in the center. And then as we go down each period, those atoms that are found on those periods, that's where we know what energy levels they have, where we can find find the electrons. And specifically, the period that it's on is where your valence electrons are going to be found. So like francium. Francium's in period 7, so that means it's going to have 7 energy levels in its atom. So each time you add an energy level, and I'm going to run out of room, but each time you add an energy level, you're adding size. So that kind of makes sense of why that is, that our atom gets bigger as we go down each period. Just because keep adding a layer to the atom. Now the reason why it becomes smaller as we move down the period is it comes back to that electrostatic interaction, or that positive negative being attracted to each other. So remember, our nucleus is positively charged, our electrons are negatively charged, and as we keep going down our period, what happens is we keep getting more electrons and we keep getting more protons. So positive and negative are attracted to each other. So if I keep adding electrons, keep adding protons, then I keep adding to what's in my atom, and it causes my atom to kind of squeeze on itself because our electrons are being attracted to the protons in our nucleus. So it kind of squeezes our atom a little bit. So makes it squeeze in just so slightly each time we add a negative electron. So for each one. So that's just a little bit on atomic radius. So our land marker for this is francium, because that's our largest atom. So the further away we get to francium, the smaller we're going to be. The closer we get to it, the larger we're going to be. So I'm going to go through number 1 real quick. So we have magnesium, silicon, sulfur, and sodium. So here you have magnesium, not too far away from francium. Then we have silicon much further away. Here's sulfur, a couple more elements away, so even further away from francium. And then lastly we have sodium. It's actually one element closer to francium than magnesium. So what's going to be our largest atom will end up being sodium, just because it is the closest one to francium. It's by an element, and it's about 4 periods up. And if you guys notice, these are all on the same period. So sodium would be the largest, it's closest to francium, and then sulfur would be the smallest because it's furthest down the period. So let's talk about electronegativity real quick. So electronegativity is ability for an atom to attract electrons. So what's going to be our most electronegative atoms are going to be our group 17 atoms. The reason why is, and this will be a big deal once we get into our next unit in ions, the reason why is because they have 7 valence electrons. Well, all atoms are trying to get 8, just like their noble gases. So everybody's trying to be like a noble gas. Well, since these only have 7 valence electrons, they will try to do anything they can in order to get that one more electron. So this makes them extremely electronegative because they want that one last electron. And in particular, fluorine ends up being the most electronegative because it goes back to the size and that positive-negative interaction. So fluorine's only on the second period, so it only has a couple of energy levels. So we would be getting rid of all this stuff on the outside. So we wouldn't be left with very much right here. So what that does is allows our nucleus to attract electrons a little bit easier just because it doesn't have all those energy levels to do so. So because fluorine's smaller and it's in group 17 where it only needs one electron, that's what makes it the most electronegative atom. So let's do number 5 real quick. Number 5. So it says, circle which one's the most electronegative. So we're going to use fluorine as our landmarker. So we have potassium, which is in group 1 right here. And then we have arsenic, which is in group 15. So arsenic is much closer than potassium over here. So our more electronegative atom will be arsenic. One last thing I forgot to mention too is the reason why everybody's trying to be like group 18 is because it has a full outer shell of electrons, or 8 electrons. That's what we call the octet rule. We'll be talking about that a lot for the next couple of units. So since they have their 8 valence electrons, group 18 has no electronegativity. So don't be tricked, when you're asked, okay, does this have, maybe it says neon. Well, neon has no electronegativity. Even though it's right next to fluorine, it has no electronegativity. So something like potassium, which is way over here, would still have more electronegativity than something in group 18. So just had to mention that. B, you have nitrogen and antimony. Well, nitrogen's only 2 elements away from fluorine. Antimony's way down here. So nitrogen definitely going to be the more electronegative atom. So now C, we have chlorine and argon. They're both right next to fluorine, but remember what I just said a minute ago? Since argon is in group 18, it has no electronegativity. So it has to be chlorine. Also, chlorine is the second most electronegative atom anyways, but I just happen to know that. And if you were to look on this P table, it does have those as properties. Finally, D, we have strontium and beryllium. So strontium, let's get over. Strontium's down here, beryllium's up here. So beryllium, since it's higher up, it's on a only on the second period, whereas strontium's on the 5th. It makes it a little bit closer to fluorine because they're in the same group, but beryllium's a little bit higher up. So beryllium would be our more electronegative atom. So I thought I'd briefly go over these just so that you guys had some examples to go off of. We'll talk about these a little bit throughout the year. Atomic radius, not as much, but definitely electronegativity. Electronegativity is going to be a big deal once we get to what's called polarity within covalent bonds. So I hope you guys have a good day, and make sure to keep on your studies. Bye.